This is the network design we will use for our discussion of IP packets. We will simplify our diagram a bit. We will take out only the part with PC1 and PC2, and that is what we have drawn down here. Let us bring up Workstation again. We can ping from PC1 to PC2, and PC2 will reply back to PC1. We only want to see one ping. It's a successful ping, one packet transmitted and one packet received. We can do the same over on PC2. We are pinging from PC2 to PC1, and PC1 is replying back. The output from the ping program shows that the reply came from the .100 address on the 1056.16 network. Make sure you have the same setup or something similar to this. For further discussion of IP packets, we will redraw our design here. PC1 and PC2 will be graphically substituted by these rectangles. We will put in the interfaces for PC1 and PC2 respectively. So this is our new box design of our Linux Raspberry on the left and Ubuntu on the right-hand side. This illustrates how PC1 and PC2 physically are connected to the network designated VMnet8. Let us bring up Workstation and do a ping from PC1 to PC2. We executed the ping program. We typed in a destination address 1056.16.100, which is our PC2 as a target over here. This execution of the ping program made our networking device PC1 create an IP packet. This is the simplified IP packet illustrated here. Our networking device has put this target IP address into the IP packet as the destination IP address, namely the address of PC2. When executing the ping program, our networking device also put in a sender IP address or source IP address. The source address is the address of the device itself, namely the .100. So this is the assembled sender address or so-called source address. An IP packet is thus constituted by a receiver address or destination address, a sender address or source address, and it also has the IP packet payload. Here the IP packet payload is from the ping program. It is a request for the receiver to send back a reply to this IP ping packet. When the ping program executes, our networking device PC1 will take the IP packet and send it out on its interface ETH0 onto VMnet8. The IP packet will be received by PC2 as it has the receiving IP address of .101. PC2 will realize that it is a request for a ping reply. The PC2 ping program will produce a reply IP packet. The reply IP packet will now have the destination address 100. It took that destination IP address from the source IP address in the ping request. The PC2 networking device will put its own IP address, namely the 101, in as the source address. PC2 will now send this IP ping reply packet out on its interface ENS33 out onto VMnet8. The .100 IP address will receive the IP packet PC1 on ETH0. The ping program will accept that this was a ping reply over from PC2. If we bring our workstation again, just to repeat, this is what the process looks like in our terminal. Sending a ping from 100 to 101, who will reply back to 100.